And just let me know if the warm-up link that I put in the chat doesn't work. And you can submit without like completing it. It's just to see where you are with it already. Since the warm-up is only like 5 questions, I'll give you guys until 3:07 to finish it. Two more minutes, guys. Okay, so if you haven't finished by now, you can, start submitting. Doesn't matter if you finish or not. I see 4 responses. Thank you to everyone who submitted. We'll start doing bases now and like base conversion. This was also another requested topic to do. Okay, cool. Okay, so for bases, the base system that we use every day is called base 10, and there's 10 digits that we use. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And some other common base systems that you'll probably hear about or see are binary or base 2, which only uses 0 and 1. Quinary or base 5 only uses 0 through 4. And hexadecimal, which is base 16, it uses 0 through 9, and it also uses A, B, C, D, E, and F. And those letters replace the numbers 10 through 15. So when we represent a number in base 10, we usually don't have to write like a subscript of 10 because base 10 is like the standard. It's also known as the decimal system. But when we represent a number in a different base, we have to specify what base it's in, and you do that in a subscript. So it's like the opposite of where you would write an exponent. So like these are some examples. Like this is 318, and the 9 shows you that it's base 9. 4120, this 6 shows you that it's in base 6, and 38A97, and this shows that it's in hexadecimal. And for the sake of our class, we won't be covering bases higher than 10 because they're kind of confusing, and you're probably not going to see them on contest math, at least for like middle school, which most of you are middle schoolers, I'm assuming. But I think AOPS has lessons on hexadecimal as well that you could check out. And one thing to note is that, let's say you're reading a number that, okay, this is supposed to, the 5 is supposed to be in subscript, but if you're reading this number right here, don't say 1234, because base 5 doesn't have like the standard thousands, hundreds, and tens, ones places. Just say 1, 2, 3, 4 to like and base 5 at the end. So let's start with converting other bases to base 10. This is the easier part. So to convert other bases to base 10, we have to understand how base 10 works. So let's take a look at the number 245. So let's start at the ones place. So how we can break this down is 10 to the 0th power, which is 1. As you know, anything to the 0th power is 1, and then times 5. So that gets you 1 times 5, which is 5. And then for 4, it's 10 to the 1 times 4. So that's 10 times 4, and that's 40. For the 2, which is in the hundreds place, it's 10 squared times 2, which is 100 times 2, and that's 200. And how you get the final number is you add 200, 40, and 5, and then you get 245. So that's kind of how the bases break down. And this applies to all other numbers, as you will see. So let's take a look at 342 with the base, 342 and base 7. So we can break it down the same way as we did with 245. So this 2 would basically be 7 to the 0th power times 2. And then this 4 would be 7 to the 1st power times 4. So that would be 7 times 4. This is 28. And then this one would be 7 squared times 3. It's 49 times 3. 147, if I'm correct. So basically, to get 342 from base 7 to something in base 10, you would add up 147, 28, and 2, and that adds up to 177 in base 10. Now, this is your turn. So it says to convert 2, 3, 4, 5 in base 5 to a standard base 10 number. And you can put your answers in the chat. I'll give you guys one more minute. Okay, so I see a few different answers. So this was actually a trick question. I don't know if anyone caught it, but base 5 doesn't have 5 in it. So this is actually like invalid, like the whole question, because the base 5, as we talked about before, it only uses 0 through 4. It's like how we use base 10, but the digits only go from 0 to 9. It doesn't go from 0 to 10. Okay, I'm sorry I did that. Now for the real question, let's do 2, 3, 4, 1 in base 5 to a standard, like convert it to a base 10 number. And I will give you guys until 3:15 to solve this one. It should be pretty much the same way how you did the 2, 3, 4, 5, except I just changed the last number. So it should be pretty much the same. Okay, so I see two people saying 3, 4, 6. So let's take a look at this. So let's write it bigger, how we did before. So the 1 is just going to be 1 times 1, or like 5 to the 0th power times 1. And then this 4 is going to be 5 to the first power times 1. So that would, sorry, times 4. So that would be 20. This one would be 5 squared times 3, so 75. And then this one would be 5 cubed times 2. So that would be 250. So when you add all of that up, it is 346. Good job, guys. Okay, just one more and then we'll move on to the opposite way. So convert 8546 in base 9 to a standard base 10 number and put your answers in the chat. I'll give you guys until 3:18 to answer. Okay, so I see 3 responses of 6, 2, 7, 9. So let's take a look at this one. I'm gonna write it out again. So the 6 is going to be 9 to the 0th power times 6, so just 6. 9 to the 1st power times 4. This is 9 to the 2nd power times 5, so 81 times 5. This is 405. And then this would be 9 cubed, so 729 times 8, which is 5832. And if you add all of those up, you get 6279 as your base 10 version of that number. So all of you guys were correct. Good job. Now let's do converting from base 10 to other bases. So this part is just a little more confusing. It's basically the exact opposite of what we're doing, and instead of multiplication, we're doing division and remainders. So there's 2 like slightly different ways of going about doing this. So first I'll show you the way of like reading remainders from top to bottom. So for this method, it's usually easier with like smaller bases like binary. So let's do 29. So binary is also base 2. So we will divide by 2 until we get the number that's here to 0. So dividing 29 by 2, that's 14R1. Divide this by 2 again, that's 7R0. Divide by 2 again, 3R1. Divide by 2, 1R1, and divide by 2 again, even though this is less than the divisor, and then you get 0R1. I know that's a little bit hard to read, but now we're going to read the remainders from top to bottom. So 1, 1, 1, 0, 1. So that's your binary version of that number. So again, this is easier to do when you have smaller numbers like that you're actually converting. And we can also double check this answer. So I'm gonna do what we did before. So this would be 1, this would be 0, because 0 times 1 is 0. This would be 2 to the 0th power, 2 to the 1, 2 to the, so 4, and this would be 8, and this would be 16. So if you add all of those up, so this is 24, and then this is 5, so that does equal 29. Now this is method 2, dividing separately. So I'm going to be converting 437 to base 5. Again, it's a slightly like bigger number. So I already wrote down these places right here. And remember, we can't have a digit before this, because that would be the 625th place theoretically, and that doesn't work because it's greater than 437. So first we're going to start by dividing 437 by 125, and that goes into that number 3 times. So that's 375, and that leaves you with 62 left over. So this number up here, so this 3 is going to go here. Now 62, we're going to take it, we're going to divide it by 25, and 25 goes into it twice. I know you guys know how to divide, but I'm just writing it out for the recording. And now the 12, we're going to divide by 5. And then, of course, the 1 goes into the 2 twice. So your answer is 3222 in base 5. Now it's your turn. So using either method, convert 5,234 to base 6. And again, put your answers in the chat. I'll give you until 3:23 to solve this one. Okay, so I see one answer of 1432. So let's take a look at this one. So I guess for this one, we can do the second method where you list out the places. Okay, so this will be 1, this would be 6, 36, okay, this is a really long number. Let's just cut off this 4 at the end for simplicity. Okay, so now we have 523. So 216, if you multiply that by 2, you get 432, and then you're left with 100. So that goes into there twice. Now with 100, we can divide by 36, which also goes in there twice. And now we're left with 28. And we divide this by 6. This goes in there 4 times. And then you're left with 4 to go into that 4 times. So the answer for 523 is 2244. And Selena, yeah, I'm pretty sure it would be 40122. Oh yeah, I think I did 532 instead of 523. I'm sorry. Yeah, thanks for pointing that out. Okay, awesome. So this is the last one, just convert 47 to binary. Okay, so Fiona said 101111, and that is correct. And Andrew, good job. We'll go over this real quick for anyone who didn't get it. So I guess we'll do the dividing method because 47 is pretty small. So dividing that by 2 first, you get a remainder of 1. Dividing by 2 again, 12, remainder 1. dividing by 2. Again, you get 6 remainder 0. Dividing by 2 again. And okay. So your answer is 101111. Okay, awesome. So that's all for that lesson. I will send a progress check link. It's only a few questions, and I'll put that in the chat and then just complete that. So I'll give you guys until 3:34 to complete this. Two more minutes for the progress check. Time's up for the progress check. So Annie will begin like screen sharing and do number theory on quizzes now. So
Before I do that, I just want to go over a quick question from the warm-up that I think a lot of people had trouble with. So for the one saying, given two positive numbers, a and b, with a greater than b, find a formula for how many numbers are between a and b inclusive. And there are a lot of different numbers. So I think it should be b minus a plus 1 if I am correct, but I got a, let's see, I got a minus b for one of them. So just basically how you do it is you're like, okay, from b to a, we have a plus b plus 1, b plus 2. So basically what you do is you just subtract um, uh, b minus 1 from all of them, and then you'll get a minus b plus 1, and then that's your answer.
yeah, and if
then
you're like confused about that, I guess you could take like two numbers, for example, like let's do 7 and 4. 7 is A, B is 4 because it says A is greater than B. So how many numbers are between 7 and 4 inclusive? So you would do 7 minus 4, and that would be 3 plus 1. So that would count for 4, 5, 6, and 7, which is four numbers. So either way would work.
And I'm going to screen share so you guys can see the quizzes we're doing today. I know we've been doing a lot of quizzes recently, but the quizzes questions are really good, so hopefully this time it'll be a lot of fun. I'm going to be starting the quizzes in a minute, so please join up quickly. You can still join during the game, but I think it'd be better if everyone just joins at the same time. And I'm going to be starting the quizzes. If for any reason you guys can't see what I'm presenting, I'm putting the code in the chat. guys can tell me if you want the music on or off, but it's a bit loud, I've heard. You guys can vote in chat if you want it on or off. I only see 5 people on there, which is half as many as there should be on there. So please join up. Thank you. It looks like about half of you guys are done, so I'm going to be creating another quizzes for the people who are done, but if you're not done, you can join in later. But please, everyone, do join. I see the ones that haven't joined, so please join, is what I'm trying to say. Also, way to go, Selena, for answering every question correctly on the first quizzes. And it's about 4, so I think we're gonna end class here. I'm gonna still leave the quizzes open if you want to do the quizzes and finish it. But yeah, bye everyone and have a good day.